Carboxylic acids are organic compounds that contain the carboxyl, COOH, functional group. They are generally weaker acids than strong mineral acids such as hydrochloric acid, HCl, and sulfuric acid, hydrogen sulfate. The general formula of carboxylic acids is RCOO, where R can be a hydrogen atom, alkyl group, or aryl group. The solubility of carboxylic acids in water depends on the size of the R group and the number of COOH groups present. Larger R groups decrease solubility, while more COOH groups increase solubility. Carboxylic acids can form hydrogen bonds, which influence their physical properties. In this experiment, two carboxylic acids were used are ethanoic acid and benzoic acid. Ethanoic acid can be produced by oxidation of primary alcohols, while benzoic acid can be obtained by oxidation of benzaldehyde or methylbenzene.
In this experiment, as we put the benzoic acid into the solution and shaked it vigorously, the benzoic is not soluble. Then we tested the solution on the blue litmus paper. As we tested it, the blue litmus paper turns to red. We do the same with ethanoic acid. The ethanoic acid is completely soluble in water and it also make the blue litmus paper red.
Benzoic acid. Slightly soluble in water because it contains a large nonpolar benzene ring. It turns blue litmus paper red because it is weak acid that partially ionizes in water. Ethanoic acid. Completely soluble in water because it is a small polar molecule and can form hydrogen bonds with water. It turns blue litmus paper red because it partially ionizes to produce hydrogen ions. For esterification, benzoic acid reacted with ethanol in the presence of concentrated sulfuric acid to form an ester called ethyl benzoate. The pleasant sweet or floral smell observed indicates successful ester formation. Heating helped the reaction occur faster, while sulfuric acid acted as a catalyst. The formation of an oily layer in water further confirms the production of ethyl benzoate, which is insoluble in water. And for ethanoic acid, the fruity smell detected during the experiment indicates the formation of ethyl ethanoate, an ester produced from the reaction between ethanoic acid and ethanol. Concentrated sulfuric acid acts as a catalyst, while heating speeds up the reaction. The formation of an oily layer in water further confirms the production of the ester because ethyl ethanoate is only slightly soluble in water. Have you ever wondered why esterification produces a fruity smell? The fruity smell is produced because esterification forms ester molecules. Esters are volatile compounds, meaning they easily evaporate and reach our nose. Their molecular structure interacts with our smell receptors, creating the sweet and fruity scent. These are some fun facts about carboxylic acids. 1. They are responsible for the sour taste many foods. The sour taste of vinegar comes from acetic acid. Citrus fruits contain citric acid, which contributes to their tangy flavor. 2. Some important medicines contain carboxylic acid groups. The pain reliever aspirin contains a carboxylic acid functional group. This group helps influence the drug's chemical properties and effectiveness. 3. They can act as natural preservatives. Certain carboxylic acids inhibit the growth of bacteria and fungi. For example, benzoic acid is commonly used in soft drinks and processed foods. Here we go for reaction of amines. For experiment 1, to test its acid base. As the procedure states in the observation given in the slide, for aniline reacts with phenolphthalein, the reddish-brown color indicates that aniline is a weak base and produce slightly alkaline solution in water. However, when it reacts with bromothymol blue, the indicator turned green, showing that the solution is approximately neutral to weakly alkaline. This is confirmed that aniline is a weak base. Next, for 1-aminobutane reacts with phenolphthalein, the reddish-brown color indicates that aniline is a weak base and produce slightly alkaline solution in water. However, the indicator turned green, showing that the solution is approximately neutral to weakly alkaline towards bromothymol blue. This confirms the basic nature of 1-aminobutane. For the next reaction, we want to test the solubility. As the procedure states in the observation given in the slide, when hydrochloric acid was added, the solution takes on an acidic state, making it soluble. After that, the addition of water makes the solution soluble since water is a weak base. Therefore, it makes the solution more basic than it was making it soluble. Also, for the dilute sodium hydroxide was added, the solution becomes partly a solution since the sodium hydroxide adds a little amount of a basic condition to the solution. In experiment 3, we want to test the reaction of amine with acetic acid. As the procedure states, observation and equation given in the slide, we can say that this experiment create a product named N-phenylethanamide. In the fourth experiment, phenylamine was reacted with bromine water. The brown color of bromine water gradually disappeared, indicating that a chemical reaction had taken place. This occurred because the amino group activates the benzene ring and makes it more reactive towards electrophilic substitution. When excess bromine water was added, a white precipitate was formed. This precipitate was identified as 2,4,6-tribromophenylamine, confirming the presence of an aromatic amine group in phenylamine. In the fifth experiment, phenylamine was mixed with sodium hydroxide solution and then reacted with benzoyl chloride. Initially, two distinct layers with an oily emulsion were observed because the reactants were not completely miscible. After shaking the mixture, a white solid precipitate was formed. The precipitate was identified as N-phenylbenzamide, or benzanilide, which is insoluble in water. The chemical equation shows that phenylamine reacts with benzoyl chloride in the presence of sodium hydroxide to produce N-phenylbenzamide, sodium chloride, and water. In conclusion, N-phenylbenzamide was successfully produced when phenylamine reacted with benzoyl chloride. The formation of the white precipitate confirms that the benzoylation reaction occurred successfully.